Intro. In the vast theater of the universe where stars are born and galaxies collide, there's a realm of mystery and wonder, a place where storms rage with fury, where magnetic fields eclipse those of Earth, where moons hold secrets that could rewrite our understanding of life itself. This is Jupiter, the king of the planets, the guardian of our solar system, a world so huge it could swallow all the other planets in our system combined. A planet that spins so fast it flattens out at the poles, where the day lasts only 9 hours and 56 minutes. Here, lightning strikes are more powerful than anything on Earth, cyclones defy time, and a single storm can swallow 2 or 3 Earths at once. But behind this familiar spectacle lies the unknown. These days, researchers have come very close to unlocking some of Jupiter's secrets, but so much still remains hidden. What lies beneath its hazy surface? Could its moons hold the key to life beyond Earth? What does Jupiter's dance of gravity mean for our fragile music? Jupiter's magnetic field. Welcome to Jupiter, the fifth planet from our Sun, a world of wonders that outshines all other planets in the solar system. Jupiter, with its radius of 43,440 miles, is 11 times wider than Earth. If Earth were the size of a nickel, Jupiter would be the size of a basketball. Its massive presence is more than twice as heavy as all the other planets combined. Jupiter's greatness lies not only in its size and beauty but also in the complexity of its structure. For example, Jupiter's magnetic field is a cosmic mystery whose strength challenges our understanding of planetary physics. Unlike Earth's relatively stable magnetic field, Jupiter's magnetic field changes shape. Recent studies have shown that it has changed in just a few short decades, a phenomenon known as secular variability. This wandering magnetic field makes Jupiter stand out significantly in our solar system. One theory for this change points to zonal winds, a large storm system that extends to depths of more than 1,800 miles. At this depth, the hydrogen inside Jupiter behaves like molten iron in Earth's core, creating a magnetic field. These storms distort the magnetic field, giving it a peculiar shape. In Jupiter's southern hemisphere is the Great Blue Spot, an invisible cluster of magnetic fields. Unlike Earth's magnetic field, which resembles a simple bar magnet, Jupiter's area is much more complex. It originates in a wider, broader band lower in the northern hemisphere and returns through 2 different points in the south. Deep inside Jupiter, liquid metallic hydrogen is formed under extreme pressure. This substance circulates due to convection currents created by temperature differences. This constant churning generates electric currents inside Jupiter, creating that very magnetic field. The irregularity of the magnetic field can be explained by the changing properties of metallic hydrogen as it sinks deep into the planet. Layers with different densities and conductivity create a complex and dynamic magnetic environment. Jupiter's magnetic field is not just a scientific curiosity, it is a grand celestial spectacle. The powerful magnetosphere creates dazzling auroras at the poles, a light show that testifies to the planet's magnetic power. In the pursuit of knowledge, we find beauty, complexity, and a deeper connection to the universe around us. Jupiter's magnetic field is much stronger than Earth's and is generated much closer to its surface. This provides a wealth of information that can help us understand the magnetic fields here on our own home planet. Jupiter's satellites. Jupiter's reign doesn't end with the strongest planetary magnetic field. Jupiter is truly the king of the solar system, reigning undivided with a court of 92 moons and several satellites, far greater than any other planet. Galileo's satellites, Ganymede, Europa, Callisto, and Io, are the jewels of Jupiter's satellite system. Ganymede, the largest satellite in the solar system, even has its own magnetic field. Europa's icy crust hides a potential ocean, a hint of the possibility of life. Callisto's ancient crater-covered surface tells a timely story of cosmic bombardment, and Io's stunning volcanic activity paints a portrait of a moon constantly changing its appearance. In previous videos, we've already explored each of these satellites in detail. In 2021 and 2022, astronomers discovered 12 new satellites orbiting Jupiter, bringing the total to 92. These outer satellites, ranging in size from 6 to 2 miles, orbit more than 550 million miles away from the giant planet. Some even take more than 550 days to complete their orbit. Interestingly, 9 of these new satellites are spinning in the opposite direction to the inner satellites, indicating that they've been captured by Jupiter's gravity. These small satellites are believed to be fragments of once larger satellites that collided with each other, comets or asteroids. When talking about Jupiter's environment, it's also impossible not to mention its rings. Jupiter's rings may not be as famous as Saturn's, but they have their own subtle beauty. These dim rings, composed mostly of dust particles, were probably formed by micrometeoroids hitting the inner satellites. The exploration of Jupiter's satellites is far from over. In April this year, the European Space Agency launched JUICE to circle Europa and Callisto before entering orbit around Ganymede. NASA's Europa Clipper mission, launching in October 2024, will make 50 orbits of Europa, offering unprecedented insight into this enigmatic moon. Jupiter's cosmic guardian role. Jupiter, the largest planet in our solar system, like an older brother, has long been considered Earth's cosmic guardian. Its enormous gravitational pull was thought to protect our planet from potential threats. But is this really the case? One way or another, the complex interplay of Jupiter's gravitational forces shapes our cosmic environment. Some astronomers believe that Jupiter's gravity acts as a cosmic shield, protecting Earth from long-period comets. These comets, originating from the outer reaches of the solar system, are often deflected by Jupiter's gravity, preventing them from colliding with Earth. Without Jupiter, these comets would collide with our planet much more frequently, perhaps even on timescales of millions of years. Historical observations, such as the collision of comet Shoemaker-Levy 9 with Jupiter in 1994, attest to Jupiter's protective role. The dark scars left on Jupiter's surface are a vivid reminder of the destructive power of such celestial objects. However, Jupiter's influence is not entirely favorable. Its powerful gravity also pushes some asteroids toward the Sun, where they could collide with Earth. This dual nature of Jupiter's gravitational pull creates a delicate balance in which protection from distant comets is offset by increased risk from nearby asteroids. A historical example of this threat comes from Comet Lexell, which passed dangerously close to Earth in 1770. This comet was deflected by Jupiter's gravity into a new orbit, steering it directly toward our planet. Fortunately, Jupiter's influence also threw it back outside the solar system after 2 revolutions around the Sun. Recent simulations have further complicated our understanding of Jupiter's role. Contrary to long-held beliefs, some studies suggest that Jupiter may actually increase the overall risk of cosmic collisions with Earth. By simultaneously deflecting comets far outside our solar system, Jupiter may be steering other nearby comets and asteroids on a collision course with Earth. Jupiter's dual role as protector and threat is a fascinating example of the complexity and nuances of the universe. Jupiter's cosmic guardian role. Jupiter, the largest planet in our solar system, like an older brother, has long been considered Earth's cosmic guardian. Its enormous gravitational pull was thought to protect our planet from potential threats. But is this really the case? One way or another, the complex interplay of Jupiter's gravitational forces shapes our cosmic environment. Some astronomers believe that Jupiter's gravity acts as a cosmic shield, protecting Earth from long-period comets. These comets, originating from the outer reaches of the solar system, are often deflected by Jupiter's gravity, preventing them from colliding with Earth. Without Jupiter, these comets would collide with our planet much more frequently, perhaps even on timescales of millions of years. Historical observations, such as the collision of comet Shoemaker-Levy 9 with Jupiter in 1994, attest to Jupiter's protective role. The dark scars left on Jupiter's surface are a vivid reminder of the destructive power of such celestial objects. However, Jupiter's influence is not entirely favorable. Its powerful gravity also pushes some asteroids toward the Sun, where they could collide with Earth. This dual nature of Jupiter's gravitational pull creates a delicate balance in which protection from distant comets is offset by increased risk from nearby asteroids. A historical example of this threat comes from Comet Lexell, which passed dangerously close to Earth in 1770. This comet was deflected by Jupiter's gravity into a new orbit, steering it directly toward our planet. Fortunately, Jupiter's influence also threw it back outside the solar system after 2 revolutions around the Sun. Recent simulations have further complicated our understanding of Jupiter's role. Contrary to long-held beliefs, some studies suggest that Jupiter may actually increase the overall risk of cosmic collisions with Earth. By simultaneously deflecting comets far outside our solar system, Jupiter may be steering other nearby comets and asteroids on a collision course with Earth. Jupiter's dual role as protector and threat is a fascinating example of the complexity and nuances of the universe. The majestic gas giant. With its swirling storms and powerful magnetism, Jupiter is an active participant in the cosmic ballet that shapes our existence. Its influence extends far beyond its own orbit, affecting the very safety and stability of our home planet. However, Jupiter is known for more than just its stunning gravity. Once you've seen it, you'll undoubtedly have no trouble recognizing this planet again. The world is a mesmerizing mosaic of colorful streaks and swirls, cold, windy clouds of ammonia and water with unique cyclonic patterns floating in an atmosphere of hydrogen and helium. Among them resides the Great Red Spot, a storm larger than the Earth itself that's been raging for hundreds of years. Jupiter's lightning is a phenomenon that has intrigued scientists for years. Unlike on Earth, where lightning is generated by the collision of ice and water droplets, Jupiter's lightning is thought to originate in clouds containing both water and ice. The Juno spacecraft recorded images of optical flashes in large cloud swirls near Jupiter's north pole, confirming previous speculation about Jupiterian lightning. Jupiter's storms are not only visually stunning but also scientifically complex. The presence of water and ice in clouds plays a crucial role in the formation of lightning. The interaction between water-ice crystals and ammonia vapor creates an electrical charge that leads to lightning flashes. This process is further complicated by the presence of mush balls, viscous, sticky conglomerates that fall downward, carrying ammonia into the deeper layers of Jupiter's atmosphere. Jupiter's north and south poles are home to rings of stable storms. 8 storms surround the North Pole, and 5 surround the South Pole. These storms, each about 2,500 miles in diameter, appear to remain constant in number. Scientists are still unraveling the mystery of why these storms keep a certain count and how they interact with each other. But the colorful bands of Jupiter's clouds are more than just pretty features, they are windows into the planet's complex atmospheric dynamics. Jupiter's swirling streaks are the tops of the highest clouds, made up of frozen ammonia crystals covered in soot. These streaks and swirls are evidence of the planet's dynamic atmosphere. Jupiter's extreme conditions are an area of unfathomable chaos and complexity, with temperatures hovering several hundred degrees below freezing and winds more than 400 miles per hour. This gas giant presents a hostile landscape. Nevertheless, the question remains, could there be hidden niches in its dense clouds where life thrives in some unimaginable form? However, the intrigue of the unknown prompts scientists and researchers to look beyond the gas giant itself to the mysterious moon Europa. The ice-covered surface of Europa holds a world of mystery. Beneath the frozen surface is a subsurface ocean warmed by Jupiter's gravitational pull. In this hidden ocean, all the conditions suitable for microbial life may be present. Jupiter's huge size, powerful magnetic field, and complex atmospheric dynamics make it an object of endless exploration. But what current missions are unlocking the mysteries of this giant planet? Current missions. NASA's Juno spacecraft, launched in 2011, has embarked on a mission to explore the planet like never before. Its main objectives include studying Jupiter's composition, magnetic field, magnetosphere, and atmosphere. As we've discussed, recent Juno discoveries have determined that Jupiter's metallicity is not uniform. Different concentrations of metals at different latitudes suggest a complex history. This heterogeneous distribution of heavy elements provides new clues about the origin and formation of the planet. Juno's magnetometer has mapped Jupiter's magnetic field with unprecedented accuracy. The findings revealed unexpected complexities, including the Great Blue Spot near the equator. The spacecraft's journey through radiation-intensive regions of Jupiter's magnetosphere also shed light on the planet's powerful radiation belts. Juno flybys have provided stunning images of Jupiter's atmosphere, including the iconic Great Red Spot and newly discovered cyclones at the poles. The spacecraft's microwave radiometer deeply probed Jupiter's atmosphere, revealing its colorful bands of clouds, storms, and lightning. Discoveries about Jupiter continue to be made. Juno principal investigator Scott Bolton of the Southwest Research Institute says, every 53 days, Juno goes soaring by Jupiter and gets doused by a fire hose of data. There's always something new. Juno's journey will continue with an extended mission until 2025 or the end of the spacecraft's life. This expansion challenges Juno to become an explorer of the entire Jupiter system, including Jupiter's rings and satellites, with rendezvous planned for 3 of Jupiter's most intriguing Galilean satellites, Ganymede, Europa, and Io. But what does end of life mean for Juno? Well, the term refers to Juno's planned death dive into Jupiter. This controlled descent to the planet will mark the end of Juno's exploration, ensuring that the spacecraft does not accidentally contaminate any of Jupiter's satellites. Death Dive is a fitting conclusion to a mission that has defined our understanding of the gas giant and its complex system. As Juno's final act, the spacecraft will plunge into the depths of Jupiter, sending data down and adding the last piece to the puzzle of our solar system's largest planet. The data collected by Juno will contribute to the goals of upcoming missions to the Jupiter system, including NASA's Europa Clipper mission and the European Space Agency's Jupiter Icy Moons Explorer (JUICE) mission. As the last echoes of Juno are swallowed up by the vastness of Jupiter, the secrets of this colossal planet will continue to beckon. What secrets lie behind its stormy clouds? What will the new missions discover? The journey has just begun, and the cosmos awaits, ever curious and ever majestic.